This project is primarily focused on Apache Kafka. We extract the data from the data source, we transform it, we load it to the destination, then create a dashboard out of that business-ready data. On top of that, we're just going to use a little Python and Snowflake for transformation and dashboard creation. This project is the best way to showcase your Apache Kafka proficiency on your portfolio. And by the way, every resource I used in this project, including files and codes, will be given to you from the links in the description. With that being said, let's begin.
Firstly, our project is e-commerce analytics. Basically starts with the data source where we get the data from and we transform it and then create a dashboard that aligns with the business requirement. When I say business requirement, it is simple. It's nothing but to the dashboard should show the daily sales data and the customer actions taken on the e-commerce website. That's basically it. And this is the data pipeline, the architecture, the whole architecture that we're going to follow to complete this project. And by the way, this project is totally focused on Kafka. When I say that, we cannot complete a whole project just with Kafka, right? But this is totally focused on Kafka. On top of that, we will also use Python for data transformation a little bit, and then we use Snowflake at the end to store the goal data. We will talk about the whole architecture. So let's begin with the first step, which is the data source. We will create our own data source with fake data. I'm not using any API or any CSV file. If I use CSV file, it won't be uh, eligible to stream the data, right? CSV file is static, so I have to have a data source which produces the data continuously. And the reason that I'm not using API here is usually APIs doesn't have any fault data, but here because we are creating the data source, and in order to replicate that with the real data that we get in real world when we work on e-commerce sites, the fault data, we're going to mock that fault data as well in this data source by writing a Python file to actually ingest the fault data in random locations, so that we then can clean that data to make it business ready. So that is how the data source work. We create our own data source which produces a fake data, and that produces the data continuously until we interrupt it manually. That is our data source, and the data from this data source will be then transferred to the raw data, the raw data stage, which is basically storing the raw data. We're not going to store the raw data. This is the raw data stage, which is just the raw data, and then we will be using Kafka streaming processing, where we process this bronze data while it is still stored in the topic. So we pull the raw data from one topic where the raw data is stored, and then we clean it while it is still in the Kafka itself. We clean it using Python, we process it, and then we store it in a different topic, same inside the Kafka itself. And that topic will be the storage space for our silver stage data. And that's why I called it Kafka streaming processing, because the source is a topic and the destination is also a topic. We get the data from a topic which stores the raw data, basically the bronze data, and then we clean it. We make it to the silver stage, which is also a topic that stores silver data. That is why I called it streaming processing. And from there, we will use Kafka and then ingest this data into a Snowflake table. And in that Snowflake we then convert this data into business ready data by aggregations and removing the data that we don't want, and doing some processing. then making it business ready, which is our goal stage, and then store it in Snowflake. And we create a dashboard in Snowflake itself. That is how the whole architecture goes. And I try to make this project simple because this project is a follow-up for our last masterclass, Kafka masterclass. Just so I want to make a project that should be easier for the people who just learned Kafka, and it should not be overwhelming. And that's why it only includes a few steps and few tools. Kafka, Python, a little bit of Python and a little bit of Snowflake, but primarily focused on Kafka. And while we do this project, I'm going to show you the practical, show you how these partitions, consumer groups, and connecting to Snowflake, all these, steps work in real time using the Kafka UI. And that's it. That's it with the data pipeline that we created. Let's step into the actual process. Now, talking about the requirements before we begin, we need Docker Desktop installed on our PC along with Python also installed on our PC. And we need a few tools that we need to install inside Python, but we will do that. But these are the primary tools. We need Docker Desktop and Python, and we need to have a Snowflake account at the end to store the goal data and create a dashboard. We will create a dashboard in Snowflake itself using Snowsite. Snowsite is nothing but the Snowflake's UI that we're going to use. So we're going to use that when we create the dashboard. If you want to uh, take out the Snowflake part totally, you can do that as well. Instead of using Snowflake, you can use any cloud platform to store your data, or you can just store it in the database. That works too, and then connect to Power BI or Tableau to create a dashboard. That's fine. But I'm going to use Snowflake here for that last part. And by the way, if you want to use Snowflake, it's totally free. You can sign up for a free trial, and Snowflake offers 30-day free trial with $400 worth of free credit that you can use in this free trial period. And you don't have to include or type in your card details or any payment methods. It don't ask you anything. You just need a unique email that you never used to create a Snowflake free trial account. That's it, and you can create one. And that's it. And there is an optional tool as well. You can also install VS Code, Virtual Studio Code editor. It is optional. You can do that, the same thing that I'm going to do with VS Code using a notepad itself, but because I'm going to explain the code while I type in, I'm going to use VS Code because that is more visually appealing to look at. So that's why. That is optional tool. That is not mandatory. But if you want to, you can. And links for all these tools that I just talked will be given to you down below in the description. So you can just click on it and start right away. Let's begin. First step is to use the Docker desktop to install Kafka on our PC. To begin with, I already installed Docker Desktop on my PC, but if you haven't installed it yet, just click on the link that I give to you in the description, and it will directly send you to this page. And here you have to choose your according to your PC. You can choose your one of these options and right away download it and install it with the default options that are available. And that's it. You don't even have to sign up, but if you want to, you can. I never signed up to Docker. Here, right here, you can see I never signed up. You can just skip the sign up process or sign in process, and this will be the home page you will land on. And from here, let me also show you about the VS Code. So this is another tool that I'm talking about, VS Code Editor. I'm going to write codes in this and then save it and then run it. Right now, I'm going to minimize them. What I'm going to do now is create a folder for our project. Instead of using UI to create folders or create files, we can use CLI because that is more professional. This is how you interact with the system when you work on a real uh, enterprise grade project. You don't have UI to create folders. You don't have any. You most probably won't be having any UI like Windows or Mac OS. You have to use CLI mostly. And this is how it works. If you want to create a folder in this location, by default, when you open PowerShell or command prompt, you will by default be in this location. So whatever you do here will be reflected to that location, which means here. So what I'm going to do now is I'm going to run. I'm going to create a folder named Kafka ecom, Kafka-ecom. MKDIR stands for make directory. So I'm going to, I did just created a directory named Kafka ecom. That is our root directory for our project. So when I run this command here, this will automatically create a folder in that location with that same name. Right, there you go. And that is empty right now. Now I entered into the folder that we just created, which is our root, a project root folder, Kafka ecom. To enter that folder, I have to type in change directory to change anything in that directory. Change directories, which means CD. CD stands for change directory. You have to type in CD Kafka-ecom. Now I'm inside Kafka ecom, which is our root repository. Root project repository. And we don't have to do anything here. I'm gonna minimize these two and open the VS Code editor. Here, I'm going to connect that folder here so I can work on that folder, the project repository. Click on open folder, navigate to our folder that we created, the project repository, Kafka ecom. Click on select folder. Now the folder is reflected here. The same thing. Whatever you do here, whatever the files you create, whatever the files you delete will be reflected to the actual location. Now I'm going to install Kafka. We're going to do that using a container, creating a container in Docker and then installing the Kafka image in that container. And the main reason of using Kafka container is I already talked about installation in the Kafka masterclass, but if you're new to this video and you never watched that Kafka masterclass, just to clarify, creating a container and not installing Kafka right away in your host PC is much more cleaner when you want to get rid of that uh, Kafka, whatever the installed tools. If you want to get rid of that in Docker, you can just remove the container and everything comes with that container will goes with it as well. Whereas when you install that tool directly on your PC, you have to, even if you uninstall it, you still have to remove that, those backup files that are created by that tool. That is the major difference. There are a lot other differences as well, but that is the major one why I'm using Docker to install Kafka. So to open a container with Kafka, we need a docker compose.yml file where we configure Kafka according to our needs. I'm going to create I'm going to create a container for Kafka, which acts as a Kafka broker, and also Kafka UI to display what's happening inside Kafka. To do that, I'm going to create docker compose.yml file. The code for this file is already written by me, and I got this code from our master class that we used. The same code. I'm going to paste it here. For the first time viewers who never watched that Kafka masterclass, I highly recommend you to watch that first before this, because this is a follow-up for that masterclass just to get the practical knowledge. But I'm going to explain what's going on here. We are creating two images. We are using two images here to create one container for Kafka broker. This is for Kafka and this is for Kafka UI. So these are the two containers that we're going to create. For Kafka, this is the image, Apache Kafka latest. By the way, we're not using Zookeeper. We're just using the latest Apache Kafka, which comes with Kraft, which allows us not to use Zookeeper anymore. And that's a replacement here. So we don't use Zookeeper. And then here, these are the ports that we defined. We use this port as internal port and this port as external port, listeners basically. These are the environment variables that we defined. Kafka node equals 1, broker controller. So this is a broker, and this will also act as a controller. Kafka listeners, and these, like I said, this is the external port that we can use to when we want to connect to Kafka from outside the container, but still inside the local PC, local host PC. You cannot use a different PC or laptop outside this environment and connect to Kafka. You have to do that. In order to do that, you have to expose your public IP of this PC that you're running the broker on in this code. But I cannot do that for obvious security reasons, and that doesn't make sense because I don't have another laptop to show you how that works. But in case if you want to use that, you can just expose your public IP address of this actual PC that you're running the container on here instead of this. But this is good when you want to connect outside the container, but inside the local host PC. And this Kafka port is an internal listener, which means you can only connect through that port to Kafka when you're inside the Kafka container, not outside. I'm going to show you the difference as well. Controller listeners and interbroker listener name. This can be anything. It doesn't need to be plain text. It can be anything. It can be custom made. But here I just left it plain text. You can replace it if you want to make it more professional looking. Kafka offset topic replication factor. It says it defines the replications of that broker. And then Kafka transaction state log replication factor, all that. And then we have Kafka listener security map. We map those ports, the listener ports. And then this is the log directory where the log file stores. This is the Kafka UI, and we will connect that Kafka UI to Kafka broker using the internal port Kafka 9092. That is it. And this is the port that we are defining this Kafka UI container. So through this portal, we can access Kafka UI. So this is basically the Docker compose file. So when we run this and create the containers, we're going to create two containers. one for Kafka UI and the other one for Kafka, which works as Kafka broker. Now let's save this. To run this, we have to head to Docker desktop here. You can do that from the Docker terminal right here, or else we can use PowerShell instead. PowerShell. I'm going to use PowerShell because PowerShell lets me zoom in, like this, so you can see it clearly when I mean, if you are watching this video in a mobile phone, you might not see this clearly when I use Docker desktop's terminal, because the wording in that terminal is so little. See that? You can barely see it. I can barely see it. So I'm gonna close this and use the actual PowerShell to open the containers in the Docker. Okay, now we are here, and this is the location where we created the docker compose.yml file using VS Code, right? The same location. Now what we're going to do is we can run the command to create the containers. We use up to destroy the containers, or to remove or delete the containers. We use docker compose down. So now I'm running the command docker compose up, which creates the containers, and I use -d as a flag, which indicates detach. If I don't use that, this terminal will be dedicated to show those logs while the containers are running. When I say detach and run that command, I can still use this container again, because it won't be dedicated to show those logs again. It'll be detached with that process. So that's why I use this flag. When I run this, there you go. It says created and started. So that says the containers are started successfully. One for Kafka broker and the other one for Kafka UI. I'm not sure how to zoom this in. That's fine. I hope you can actually see this. Okay. So this is the Kafka broker with two ports, one with the internal port, one is the external listener. And we have Kafka UI with one port, which is 8080. To access Kafka UI, you can go to http localhost-8080 like it says, or you can just from Docker desktop click on this port right here, left click. This will redirect right away to a web browser opening that port address, which is localhost 8080. This is a Kafka UI. I already talked about this UI in the masterclass, but I'm going to talk about it again for the first time viewers. So here, this is the dashboard. It shows everything that's happening inside the broker. The brokers, we right now we only have one broker, and here's the topics. Whatever the topics we create will be visible here. Right now we don't have any topics, and all the consumers that are connected to this broker will be viewed here. Right now there are no consumers there, so this is empty. We're done with that. Now our initial setup is ready. Now what we have to do is we have to create a producer, to generate the data, the fake data, with the faulty data inside mixed with that, and move on after to the later steps. So yes, let's create that. But to create that, we are not going to create that right away. Before we create the producer.py, we're going to initialize our virtual environment inside our project repository. And the reason we are creating a virtual environment is, there are a lot of reasons, but me primarily creating these virtual environments because of the same reason that I'm using containers instead of installing Kafka on my local PC. Because when you use virtual environment and whatever tools you install in that virtual environment will be taken away, will be removed if you remove the virtual environment with it. So that is a lot easier to remove, and also to keep the version consistency. If you install any tools in that virtual environment, we can actually track those tools that are installed in that environment independent to the local PC. So if you want to exactly replicate that project or that environment in any other PC, you can replicate it just by installing those tools that are installed in that virtual environment and not the local PC, because the local PC has nothing to do with that environment. That is one more reason, the consistency. Now, to initialize the virtual environment, the command we have to run is, like I said, you need to have Python installed, and the Python version should be anything over 3.10. The version should be about 3.10. So yes, to create the virtual environment, write that. We can change this name, by the way. It doesn't supposed to be venv. You can change it to Kafka venv or Python venv. I mean, let's say, yeah, Kafka venv. You can just change it to anything you want, but I'm going to use venv for the name as well for of the folder. Hit enter. That's going to take a few seconds to create the environment. There you go. If it returns nothing, if there is no errors popped, that means it is successful. There you go. So, and if you go back to the project repository, you can actually see a new folder that is created, venv. Under that, there are a lot of files and folders created inside. Now, we did actually create a virtual environment, but before we start the process, we have to activate the virtual environment. To activate it, we're going to run venv, whatever you named your virtual environment. I named it venv, nothing nothing different. So I'm going to use venv /scripts /activate to activate the virtual environment. We're basically navigating to venv scripts activate. Where is it? So we're just navigating to that file to activate the environment. That's it. Now the virtual environment is activated. So whatever you do in this environment can be replicated to another virtual environment so easily. And if you want to get rid of all those tools, you can just remove the virtual environment, and all those tools will be gone with that environment. There is a command that to actually see what are the tools installed in this virtual environment, and the command is pip freeze, and this will list all the, this will create a folder. Let me show you. Right now I haven't installed anything, and that's why it didn't show it. I didn't show anything at all. But if we install a tool, let me install a tool. Now we need the tool to actually connect to Kafka, and the tool name is Python. Let me see. I think it's Kafka-Python. So we need that tool to connect to Kafka through Python. So let's install it. Yeah, that's the tool. Now we installed it, collected using installing collectors. Successfully installed Kafka Python, and that's the version. Now I did install a tool inside that virtual environment. So when I run that, pip freeze again, that lists the tools and the versions of that tool that is installed that in that environment, right here. So when you want to replicate, you can just install that tool with that particular version to exactly replicate this virtual environment in any other PC. Now we got that. And to make it easier for anyone to recreate this project, we basically create another folder, not inside VNV, here in the root repository, saying requirements.txt, and we will list all the required tools and their versions, their appropriate versions to be installed in the PC in order to replicate that project. Not in the PC, by the way, in the virtual environment. So here, what we're going to do is, no, instead of creating that, we can just run a command that creates the file. Let me delete it. And the command for that is pip freeze, and that output should be saved in a file. To say that, we say greater than symbol to just represent that as an arrow, and the file name that we want to create, we want that information to be saved in, is requirements.txt. Now when I run that, it automatically creates the file with all the tools and versions that are installed in that virtual environment. So when someone create a virtual environment in a different PC, what they can do is they can just run pip install, I think it's -r requirements.txt. Now it will install every tool with the versions that are given, that are assigned in that virtual environment. And -r stands for the flag, the -r, the -r is a flag to say to read that file. So the flag says read. So it reads the file, everything in that file, and installs using pip. That's how it works. Let me take that down. Now we have that file ready. Now let's create the producer.py, which generates the source data. To do that, we have to create a file in the root repository, say producer.py, and here is where we're going to write the code to generate the data. Let me just zoom this a little bit. View. Zoom in. I think that's enough, right? Yeah, that should be fine. To begin with the producer.py code, first, we need to import the modules that we need to work on. And that includes JSON. We need JSON to work on the JSON files because we're going to generate the data, and we create a dictionary, and then we convert that dictionary into JSON file and then encode it to stream it. When I say encode, if you don't know what encoding is, let me tell you. Whatever the file you want to send, whatever the information or file or the data you want to send through Kafka, Kafka can only send that in bytes and cannot stream it using stream it as files. It should be in bytes. So in order to stream that JSON file or dictionary, we have to first encode that file. So it converts that file into binary bits and then can be streamed using Kafka. And when you receive it, we decode that. We encode it at the producer and decode it at the consumer. And that's how the streaming connections work. Okay, we need import JSON so we can get those JSON methods that we can use. We definitely need random to pick random data. And we need to import time to use that. And for sure, we need Kafka producer to be imported, because this code will be connected to Kafka as Kafka producer. So we need Kafka producer to be imported. I think we still need more. We still need to import more modules, but I don't remember those. We will import them. We will type. I'm going to type them in when the time comes. But first, let's talk about producer. Firstly, we need to define the listener, which will be the Bootstrap server. We need to define the listener through which we can uh, send the data so that Kafka can stream the data. And I just defined it with a variable bootstrap servers under bootstrap underscore servers, just to make it much easier when we read that code. So just for the readability, I'm going to separate that. And here is where I'm going to type in my port. And the port that we defined is the external port is this host.docker.internal 29092. This is the external listener. We have to define it here. We can right away write it in this part, but just for the readability, like I said, I'm going to define the variable first and then call the variable here. Okay, that is done. And then we use key serializer, because the data that we're going to send will be key value pairs, just not the values. We're going to send it in key value pairs. To segregate according to the users, I'm going to separate them with keys. And the keys here will be the user IDs. I chosen this to make it more accurate with a real world project, because in this project we're going to create a topic with multiple partitions in it. And we all know partitions only support order in one in that particular partition and not across all the partitions in the topic. When I say that, what I mean is the data that we're going to send to a topic, if the topic has 3 partitions, we don't know which record goes to which partition, but we can control the data that to go to that particular partition by assigning keys to that data. When we assign keys, all the data that has the same keys goes to the same partition, which allows us to save the data in order and not, you know, unordered. But if we don't have a key for that particular data, let's say if the data is about user creating an order and then paying the order, if the customer creating the order goes to one partition and that is at at that is the 4th record in that partition, and user paying the order goes to a different partition and that is at the top or at the 2nd record of that partition, there will there will not be any the sequence or order for that events. To avoid that, to make them to arrange them in order, we use keys to make sure the data with that key or the data with one particular key goes to the same partition. That's what we are going to do here. Key serializer lambda k. We encode the serial the key first. Like I said, everything should be encoded before it gets streamed in Kafka. So we use that. And if there is no key specified or defined for that record at all, we we uh, we just send none. Yeah, that's it. So we just say if k. We are using if condition to check if k is not empty. If it is empty, it just says none, or else it gets encoded. That's how the logic goes here. And then if we do and then we serialize the value as well. We did serialize. We did use key serializer. Now we use value serializer to encode the actual data, and the actual data will be given as JSON. No, the actual data will be in dictionary, and then using json.dumpsoft, we are converting the dictionary into a JSON file, and this JSON file will be then encoded into bytes using encode of UTF-8. That's it with the producer. And then we create a list. List of strings. That stores all the strings that says one says page view, add to cart, purchase. So these event types are to track the customer behavior. If the customer views the page, it says page view. If he adds to cart, if he adds any product to cart, it says add cart. And then purchase is purchase. We created a list of them. We then randomly choose one for each record. for every event. Then we also create invalid event types, just to ingest some false into the data. Now we create a function that generates the data. So it generates one record for every time it gets called. Now we're creating a variable which is valid, is underscore valid, say is underscore valid equals random dot random of less than 0.25. What random dot random of does is it generates a decimal number from 0 to 1. It can be 0 to 0.99. Now why we are doing that is, I want to insert the false data and that should be random, but I don't want all my data or almost 50% of my data with the false data. I want that false data just be 25%. To ensure that, now I just created this where is valid gets true only 25% of the times. You get it? This is the logical operator that is this the logical operator? Yeah, we're using the logical operator. So only if the random dot random of generates any decimal number which is less than 0.25, only then is valid will be true. So that is just 25% of chance to actually is valid to get to be true. So yeah, we created that variable. We will use that variable later. Then you will understand what we're doing. Now we create another variable, customer ID equals, we used f strings here, which means anything you write here will be taken as a string. So this whole thing is just a static string. But if you use flower brackets inside f strings, that will be a dynamic string that will be created. Here, this whole part is a dynamic part where we use random.randint of, we use randint to pick a random integer from a given range. Here the range is from 1 to 5, so it picks a random integer from 1 to 5. So we use that to create the customer ID. So it creates a random customer ID every time it gets called, and the the ID will be in between 1 to 5. Now we create another variable which is event type. Like I said, whenever this function is called, it should generate one event at a time it is called. So that's why we here, when we run this, when this get executed, it creates a random customer ID with cust underscore is static, and the ID will be dynamic. It changes from 1 to 5. Whereas event type, it also chooses randomly. We use a random.choice of to pick a random object from a given list. Here, random.choice of event types. This is the list that we are defined already. This is the list. And that list has page view, add to cart, purchase. And it picks one, chooses one randomly every time it is executed. That is one more variable that we use. And then now this will be one more column for us. So we created a variable for that, saying amount equals round off. We'll talk about that later, but first, random.uniform picks a random decimal number from a given range. And here we define 10 to 500. So it picks a random decimal number from the given range 10 to 500. And then whatever the decimal numbers be, the decimal points will be rounded to 2. So it just gives 2 decimal points after that, the point. Decimal values after the point. So we rounded up using round off, and 2 as the round off factor. And the currency be USD. Now what we're going to do is we are going to say, we're going to create a if condition which to see if the generated random decimal number is under 25% is true or no. So we say if is valid, That's it. We used if condition here to check if isValid is true. So we say if isValid, if this returned true here, the bool variable, if it returned true here, if it is true, then invalid field equals random dot choice of customer ID, event type, amount, currency. If it is false, it will stay none. The invalid field value will stay none. But if is invalid is true, the invalid field will be assigned with one of these strings in the list. Can be customer ID, event types, amount, or currency. And the reason that I define this condition is, like I said, 25% of my data, of my events should have errors. Yes, but all those error records doesn't need to be completely have invalid data. It only that event only should have either customer ID as error, or event type as error, or amount as error, or currency as invalid data. So only one of these columns will be invalid and the rest will be valid, just to make it look more random. And that's why I created this. So it picks only one column name, one string, which will be our column name from this list of strings. So if it picks customer ID, for that record, customer ID will be an invalid data. And now we create the actual dictionary. This will be, the first column will be event ID for our data, and we use str of UUID, which is a universally unique ID that we're going to create using UUID4 of. To use that method UUID, we need to import it at the beginning. So we're going to add one more import, is import UUID. Perfect. Now, for the customer ID column, we check if the invalid field is equals customer ID. So let's say if isValid has that 25% chance and got the bool value as true for this. So when it says true, so the event should have one fault in it, no matter what column it is. And when we check isValid is true, and that is true, and then we assign one string from this list of strings randomly to invalid field, right? And let's say randomly it picked customer ID. Okay, then when this gets executed, customer ID will be assigned with none if invalid field equals customer ID. So if invalid field picks customer ID, this event will have customer ID as none, so no customer ID at all. So that will be a false data, right? So that can be a case. Else, if invalid field doesn't pick customer ID, then the actual customer ID that is generated at the beginning here will be assigned to the customer ID with no false at all. That is how the logic goes. And then the same thing. For event type, use random.choice of invalid event type. So it chooses randomly from this list, click view pay, which is invalid event types. These are the invalid event types. They should not supposed to be in the events because those are fault data. So only do that when if invalid field, let's say this 25% matched, and then is valid is true and it goes to this, invalid field is assigned with randomly with event type. So if that is satisfied, that condition is satisfied, then choose randomly from invalid events. Or else if that is not satisfied, it is not, event type is not assigned to invalid field, then event type which is this. So then assign this event type, which chooses randomly from valid event types, not invalid. So valid event types, it can be page view, add to cart, purchase. These are the valid event types. That's how we ingest that false into the data. And same with the amount as well. The same thing. It checks if invalid field equals amount. If yes, that is satisfied. Random.uniform of -500 to -100. Random.uniform of picks, obviously, a decimal value from a given range. And the range is from -500 to -10, which is a faulty data. Amount is not supposed to be negative, right? The purchase amount should be in positive. So there is a faulty data. If that is not satisfied, assign the amount right away. I mean, as it is, which is this, which is random.uniform of 10 to 500. And the next column The same thing. If invalid field equals currency, then assign none to currency, which is invalid. If else, just assign currency, which is USD by default. And this is when the event timestamp, so when the event got generated, the timestamp when the event get generated. What we use here is datetime mod. Oh, we haven't imported datetime module. We need datetime module for that. So import from datetime, import datetime. We used it here. So we assign the event timestamp with datetime.utc now.iso format. UTC now, by using that method, we get the current time, the current whole timestamp, which includes hours, minutes, and date as well. UTC with UTC says to get the time which is in coordinated universal time, which is same throughout the whole universe. Throughout the world. So that is what UTC now means. So it gets the present time in universal, the coordinated universal time format and universal time, and then that will be converted to ISO format. When we use this part alone, it still gets the time. We can read it, but that time is in Python format. But we have to convert it into ISO formats so that it can be valid, can be read by other tools as well, other than Python. So to convert that, we use ISO format to convert it. So now it is not just in Python understandable format. It is in the format that can be understandable with anything else, any tool as well. That is how that works. And for our next column, and this is not necessary because there will not be any sort of uh, I mean is valid column in real life, but here for this project, because we are wantedly adding these false, we can create this column saying is valid, and we can record if not is valid, which means not is invalid, which means this will be true if is valid is false. So that's what we use not here. So we just, for every event, we also uh, track if the event is valid or not. It is just for us to see how these random false getting ingested and which record is faulty and which is not. These not, I mean, I'm using this just to show you how the data is going to ingest, the fault data is going to ingest into the actual data, but this is not necessary anyway. So this checks not is invalid. This checks this one to see if it is true or false. Wait, this is supposed to be is invalid and not is valid. Okay. So that checks this variable and assigns is valid equals true or false. Then we also use this column to see if is valid is false, then which field is faulty here. So we paste the invalid field here, which is this. So in that event, we'll know which column is faulty. These are just for us. These are not part of the project, just for me to show you which columns and in which intervals these faults getting ingested. Okay, we got that. And then it returns two values. The first one will be acting as a key, which is the customer ID, and the other one is the actual data, which is the whole event. We got that. Next one will be, we're going to print this is just a static string. We're just going to print starting Kafka producer before the Kafka producer actually generates the data, to just show you, to just for us for the tracking, just for us for tracking the records, I mean, tracking the logs. So we can confirm until this part, everything got executed successfully and nothing got any error, syntax error. We print that static string there and then we start the loop. We use while true, we use while loop and we use while true just to create an infinite loop. It never ends until we break it. We break it in the code, or if we don't break it in the code, we have to interrupt it while we run that in the CLI. So every time the loop loop starts, the first step will be key comma events equals, we call the function generate events, which generates one single event for every call, which is this, this whole function. Now we're calling that, and that generates one key. Just no, it returns two values. One is this, and the other one is this. And the first one will be assigned to the variable key, and the second one will be assigned to the variable event, which is the actual data. So that is called and assigned to these two. After that, we need to send these key event pairs to the Kafka broker. In order to send that, we have to create a topic inside the Kafka. We haven't created one yet. So what I'm going to do is I'm just going to define like that, topic name, and then assign the actual topic name after we create that topic to this variable, so it get automatically assigned to that producer, like that. And our topic name goes between these two double quotes, then will be assigned to this producer dot send. And for every event that gets streamed or produced, the key will be the key and the value will be the event, which is the actual data. Now what we did is, we, for every loop, for every event gets produced that is sent to Kafka stream, we print what got generated as logs. So if that is executed and then it is printed, this will be the static part. Produced event key, and the key will be the actual key that is sent will be printed here. So we know for which user that particular event got produced, because key is nothing but the user ID. So that will be printed here. The user ID will be printed here. And then to say if the event that is created, that is produced, is a valid event, we're going to track it using this. Valid equals event of is valid, the column that we created here. So if is valid is true, a valid event got created to that user ID, or else an invalid event got created to that user ID. We will track that. Lastly, we use this method to delay the loop. So once the loop got executed, once it executes all these steps, when it reaches this part, before it executes again, it waits for 1 second. It waits for 1 second and then executes the loop again. So just to simulate the delay between the event generation. So we say here time.sleep off. So it sleeps for, when we say 1, it sleeps for 1 second. If you want 2, you can just say 2. So, but if you want 5, you can say 5. It's up to you. That is how that works. And with that, the producer code is ready. All we need to do is create a topic in Kafka and then paste that topic name between these codes, which will be assigned to topic name variable. Then we used in the producer.sendOff. Now let's do that. Let's create the topic. To create a topic, we go to the PowerShell again. We open the PowerShell. Now we have to enter the Kafka container using that command. When I run it, now you will see this thing pops up. This will be a random ID that will be generated. Now everything you run here, you're running it from inside the container, not from the local PC. After that, we navigate to that folder using CD. CD, like I said, CD stands for change directory. Run this command to go to that folder, bin folder, where all the bash files of Kafka is present. Let me show you. If I run ls, let me zoom this in a little bit like that. So yeah, if I run ls, it lists out all the files and folders inside the folder, the bin folder. Now here we see a lot of .sh files. .sh files are nothing but bash files. Now depends on your action that you want to perform. You want to call one of these bash files and then perform it. For example, if you in our case, we want to create a producer. We want to create a topic, not a producer. We want to create a topic. So to create a topic, there is something called Kafka topics.sh. You call that and say create and then topic name and then the variables, the configuration. You have to give the configuration. That's how it works. If you want to use a console producer, we call Kafka console producer.sh. That's how these commands work. I know I did talk about these things in the Kafka masterclass, but this is a follow-up, and I'm explaining these things again for the people who are watching this video for the first time without watching the Kafka masterclass. Now, to create a topic, like I said, we have to use this bash file, which is Kafka topics. Where is it? So this one, Kafka topics.sh. Dot backslash and say Kafka topics.sh, which I already said, and then hyphen hyphen create, because we are creating the topic here. Use create and say hyphen hyphen topic raw underscore events. So we're creating a topic and the topic name as raw underscore events because we're storing the raw events in that topic. And then hyphen hyphen bootstrap server, and here we define that port, the listener that we can talk to Kafka. Since we are inside the container, we can use the internal port, which is Kafka 9092, or else we can still use the host, the external port as well. Both of them works here. So first I'm going to show you by using the internal port, which is Kafka hyphen, Kafka colon 9092, which is the internal port, hyphen hyphen partitions 3. Now for this topic, I'm defining the partitions as three partitions. So this will have 3 partitions. And replication factor as 1. If I run that, hit enter, Okay. I typed it wrong. I typed topics. I spelled it wrong. So I'm gonna just copy that into a notepad like that and add C here because it is hard to edit something that we already typed in CLI. Now right click, copy, paste it. Now run it. Create a topic raw events. So that says the event is created. Now let's head to the UI again. There you go. Now when we switch to topics, well, it does says topics, created topics raw events. It might take a few seconds to reflect in the UI. There you go. Raw events, partitions 3, out of sync replicas, replication factor, number of messages. We already talked about in the master class about these things. And there you go. The partition IDs starts from 0 to 2, 0, 1, 2, 3 partitions. Now the topic is created. Now let's copy this topic name. And paste it in our producer code right here. Raw events. Now that is done. And I forgot one more thing. So to confirm the topic is created, we can see here, or we can, if we are using Kafka UI, we can see here. But when we work on the real system in real project, in real world, we don't have we cannot use Kafka UI. I mean, yeah, we cannot use it because we work on a virtual machine. In that case, there are commands that we can use to see list of topics that are created and description of the topics that are that a particular topic. I'm going to show you those topics as well, so that you can confirm. Just in case if you're not using Kafka UI, you can do this instead. And the Bootstrap server, which is this. Copy that. Paste it here. Oh. Then run it. Now this will list all the topics that are created in that broker. That is one way. That is how we list all the topics that are created. Now, to describe a particular topic, we can use the same bash file, Kafka topics.sh. And the Bootstrap server. Like I said, you can use this port or you can use the same port that we used. So I'm going to use that port instead, this one, the external port, to show you both works. Because we are running these commands inside the container. When I do that, hit enter, there you go. It shows the topic name, which is raw events, topic ID, partition count of that topic, which is 3, replication factor, which is configured as 1, configs, and for every and it also displays every partition separately. Partition 0, leader 1, replicas 1. We already know about these things. We talked about them in the master class. They are the extra parameters that displays and all that. So yeah, that's how we can see or describe a topic or view what are the topics that are present in the broker without using UI. Now we have the code ready, we have the topic created. All we need to do is run this producer code and send data to the Kafka. To do that, after saving this, go back to bash. Now, because this is inside the container, I'm gonna open a different PowerShell, a separate PowerShell. Kafka, I think I named it ecom. And then venv. From here, I'm going to run the producer.py. Run it. Okay, we did got an error in the code. It says syntax error, invalid syntax at line 33. So in our code, line 33 is this. Error at amount. So it says line 33. When it points to a line, you have to also check the line on top of it and line at the bottom of it. And here the error is not at line 33. The actual error is at line 32, which is this. Instead of using a comma, I used a dot. Now I replaced it with a comma. Run the code again. Copy, paste, run. Another error, the same syntax error, invalid syntax, perhaps you forgot a comma. Again. And that is at the line 41, which is this. Well, it says maybe you forgot a comma here, but the main reason is I spelled the choice wrong. CHOICE, supposed to be CHOICE. Random.choice of and random.uniform, UTC, and yeah, that's it. The same thing at the top as well. Here it's supposed to be C here as well. I think that's it. Now let's save that. Let's try running that again. Okay, that's not the problem then. So it does say invalid syntax, perhaps you forgot a comma. Yeah, the error was direct. I forgot a comma actually. So for every line, for every key value pair in dictionary, they should be separated with a comma, right? But here I forgot a comma. It should be here. Like I said, it says the error is at line 41, but the actual error is at line 44 because this whole thing is one single key value pair. So you have to check on that, and also a comma here at the bottom as well. I missed that. Also here and here. Okay, now this should be fine. Now the error is the name producer is not defined. Do you mean producer? Okay. Yeah. Here, these about the name error, which is when I define the producer, I used capital uppercase P, but when I used it at the bottom, I used lowercase. That's the error. Now, when I replace it with the capital, the uppercase P, now this should be fine. There you go. Now it works. I know I got a lot of errors, but that's how we code, right? When we write a long code, usually for me, I'll get a ton of errors every single time, but we have to know how to fix it. Now, the events are getting generated, produced one for every second. And with our probability of ingesting the errors, which is 25%, you see the invalid data is randomly produced and ingested. Here, valid equals false, valid equals false, valid equals false. Here, the key is none, because in this if condition, in this random.choice, customer ID got selected, and that's why that is none. That customer ID got the invalid value. Okay, so these are generating. So to stop this stream, like I said, we created an infinite loop using while true. The only way to stop it is we write a break. We break the loop inside the loop here itself in the code, or at the runtime, we can use control plus C. That breaks the loop, and that makes the loop so that we can exit the loop. Yeah, so that we can exit the loop. So that's how we stop it. Now let's go to the UI, refresh. Now here it says the number of messages are 89. So we produced 89 messages using producer.py. So 89 events, 89 records basically. And to show you how partitions work, this is how they work. We cannot tell this key should go to this partition, but what we can say is every value that is assigned by this particular key should be saved in one partition. That's it. We cannot define which partition it should be saved. We cannot say it should be saved in partition 0 or 1. We can say all the values that are assigned to one key should be saved in one partition and one partition at that's it. So let me show you. Switch to messages, and you can see the key customer 5 is first saved in partition 1, which means every key with customer underscore 5 should go to the same partition, which is partition 1. So here, partition 1, let me zoom it. There you go. Customer 5 went to partition 1, customer 5 went to partition 1, and another customer 5 here which went to partition 1. Let me filter it. Keys. Maybe I can search for it. So only customer 5 will fill. Yeah, there you go. So every key, every data, every value that has a key as customer 5 will be saved in partition 1 alone. So customer 5, all of them are saved in partition 1. That's how it works. With this, the same thing with customer 3, which went to partition 0, and every value that is assigned to that key, the customer 3, will be gone to partition 0. There you go. And let me check for one none value. There you go. This is the one. But these null values can go to any partition. So here, this null value went to partition 0, whereas this event with no key at all went to partition 2. And this one went to partition 0 again. This one went to 2. This one went to 1. So that's how it works. If there is no key, they will be given to random partitions. If there is a key, all the values that are assigned to one key should be saved in one partition alone. That's how partitions work. Okay, we have that cleared. Now we generated how many? 89 messages. Now, I have one last thing to say about the producer. Here, we are generating the data, but when we capture the event timestamp, all the events will be generated on one single day. That makes hard for us to when we create a dashboard, because we have to run the same producer multiple days to have multiple event timestamps. But for this project, because I want to explain it today itself, what I'm going to do is I'm going to modify this producer code a little bit to add multiple days. So it produces the events in multiple days. It can be starting from today to the past 6 days. So it can be yesterday, it can be day before yesterday. So like that. So instead of all the events being generated on the same day, they'll be generated in past 6 days. And I have that code ready with me. I'm going to copy paste the parts that we need, just the parts that we have to modify. And by the way, I will give this code that generates the past 6 days to you guys in the GitHub. But if you want this actual code and you want to run this multiple days to get the actual, if you want to do that by yourself by running this producer for 6 or 5 or 4 days, you can do that. But if you want to do the whole project in one single day, you can just copy paste this code that I'm going to give you in the GitHub. Or else you can just take down the parts that I'm going to add now and use this actual code. So to actually add that delay, what we need is we also need time delta to be imported here. And then we also need, not sure if you can see this, I'm going to zoom it. And we also need this function. This function adds that delay, that the past dates, not the delay. It adds the past dates. I'm going to paste that function here. And then this line, the event time should be, where is it? So here, event time should be this. No, it should be this .iso format, because that returns the timestamp in Python that Python can understand, but not ISO, not any other tool. So we have to convert it to using ISO format of. So that converts that into ISO format. That's it. Now, when I run this, this will produce the events that that looks like they are produced 6 days before or 5 days before randomly. Okay, that is good. Now let me delete all the records that are on the topic. We can do that in using CLI, or you can just do that from this UI itself using clear messages from all the partitions. That simple. Yep. Now run this again. I'll leave it to run for a few minutes. So I'll keep it aside. And moving on to our next step. Let's go to the architectural diagram. Now we're done with the data source. The data source is here. We're done with this one and raw data. We have the data source. We have the data source and it is stored in the raw data stage, which is it is in the bronze data stage, which is stored in the raw events topics. Now what we have to do is we have to use streaming processing, where we consume the data and then process the data, and then again use a producer to send the data into another different topic. So we're going to do this silver clean data step. Let's do that. To do that, I'm going to create a new file, name it streamprocessor.py, and import the modules that we need. Of course, we need JSON because remember when we encoded the data, we did converted that dictionary into a JSON, which is this right here. We use json.dumpsoff to convert the dictionary into a JSON file. So we have to convert it back to a dictionary to actually manipulate the data. So we do need JSON module again. And then we need Kafka. We need to import Kafka consumer and Kafka producer from Kafka, because we're going to use both. We use Kafka consumer to pull the data out of the stream, and then after manipulating it, after cleaning it, we have to push the data again into a different topic into Kafka. So we need both modules. And the Bootstrap servers, of course, the same port, the external port. Let me just copy paste it here from the producer. And the input topic is raw events. Raw events is the topic where we get the input data from the raw data. And then we define output topic where we send the events to, the cleaned events. We have to create the topic. We haven't created that yet. Should I create it right now? I will. Yeah, I will create the topic right now. So I'm going to use the same command that I used before to create the topic. Copy that. Paste it in the notepad. And here, right here, instead of this raw events name, I'm gonna name it clean events to represent the cleaned events topic. Now copy, paste it here, run it. That creates another topic named clean events. Oh, I have to stop this stream. I forgot. I stopped the stream. Okay. Oh, I think it produced a lot of records, like 300 records. That's fine. 300 messages. And this is a new topic that we created with 0 messages. And you see that after 59 records got deleted from the partition, the offset still starts from continues from the last offset. So the last offset that was before is 59. Now that is the first offset because we deleted the rest of the 59 records, but still the offset starts from 59 again, not from 0. And it ends at 249. Okay. Now we have 300 records. That's fine. Now the output topic, we have it as clean events. I will talk about group ID. We're just defining the name of the consumer group ID that we're going to create. We're just going to define all the variables and then use it later in the code. I'm going to name the group ID as Silverstream processor. What are the valid events? This one. I'm going to first define the list of valid events so I can filter them out in the fault records. Okay. Now I'm going to define the consumer through which we can get the data from the stream. I'm going to keep it lowercase c because last time we used uppercase P for the producer. I got confused. So I'm going to use lowercase here. Consumer Kafka consumer input topic, which will be the topic name for the consumer to consume the data from. And then bootstrap server equals the server that we defined, comma, and group ID is this. So we're defining the consumer group ID for the consumer. Auto offset reset equals earliest. So if while reading the data, if the consumer goes down and if it continues again with the same consumer group ID, it won't start from the beginning. It won't start consuming the data from the beginning. It starts where it stopped before. That's how the earliest works. If you say latest, no matter how many times you run the consumer, if it broke, it starts from the beginning of the data and not the last checkpoint, last offset. We say enable auto commit equals true. So right after we consume the data from the using the consumer, right after we consume an event, the offset gets saved, offset get committed. Here we need we use serializer when we produce the data. When we send the data to Kafka, we use deserializer to decode. In producer, we encode it into bytes, and when we consume the data, we get the bytes, right? Now we have to decode them in the same format to to reconstruct the format of the actual data. To reconstruct it, we need to decode at the time of consumption, like we talked before. That's what we did here. And here, this is supposed to be loads. We use json.dumps off, which we used here to convert a dictionary into JSON file, and we use json.loads off to convert a JSON file back to dictionary. That's it. Now we define the consumer. Now say we're going to use the same bootstrap servers for this producer. Obviously, so the same listener, right? And then for the serializer and deserializer, we're going to use these two exact lines that we used before in the producer. There you go. Yeah, and that's it. Now we define the actual function, the data processing step. Process the data, define a function, say not in valid event types. So the main purpose of creating this function is to check if one particular event is valid or it has any false data in it. So we check using multiple if conditions in one function. So we use first if condition. If not event.get of customer ID, we use event.get of customer ID because we read the event using consumer, and to get the actual value we use event.get of customer ID. So it only checks that customer ID, and we use if not. So if the customer ID is nothing, is a none, then the condition will satisfy, and then that returns false. If event.get of event type not in valid event types, which are these. So if the event type is not in one of not any of these event types, that will be a false data and that will return false. The same thing, if event.get of amount is none, should not be none. If it is none, or event.get of amount is less than or equal to 0, which is a negative amount, both should return false from this function. And if not, event.get of currency, return false. If the currency is a null value, return false. If event.get of is valid is not true, return false. Same thing, if the is value is valid is a boolean type. So if it is not true, which means if it is false, return false. If none of these conditions satisfy, then only then it returns true, which means that event is valid. That's why we created this function. We will use it in the next function and you will know. Not in the next function, when we use the consumer. Then say dot 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 dot. Just for the logs, it shows starting silver stream processor if everything goes fine on the top of that particular print statement. So that's just for the logs. We print a static string here that says starting silver stream processor. Because this project is mainly focused on to display how Kafka works, we don't do much of a data processing here. But if you want to go deep into data processing as well, you can check out the other projects that we did, and those projects are listed in the modern data stack projects, the playlist. You can just check them out. But in this project, cleaning is nothing but we take out all the faulty events and just send the events that doesn't have any faults in it to the silver events topic. To do that, we get the message from consumer. From that message, we separate the key and end the event. So key equals message.key and event equals message.value, which is the actual data. Then we use if condition. If is valid event of event. So now we are sending this, we are passing this event, which is the actual value of the data, into this function. If event doesn't have any of these invalid data in it, invalid columns in it, it returns true, which means the event is not faulty. If the event has some sort of fault, it has any of these columns as faulty, it returns false. That's why we used if. If this function returns true, only then this will be executed, which is producer.send topic equals output topic. So we're sending the topic, the events to the producer, to the topic using the producer. And the topic is output topic, which we created, which is clean events. And the key and the value will be separated again. Keys equals key and value equals event. And after we send that data, we also print a dynamic string using f strings. Well, this, like I said, this part is static, and anything inside the flower bracket is dynamic. So it prints that particular key of that event, which is just sent to the topic. And then event type, it it also prints the event type that is also dynamic. Else, if the record is not sent to the topic, if it has fault data, then this will be executed. Else, print dropped key equals key, the key of the key of the data, and the reason equals invalid. That's it. And it will, that faulty data will never be sent to that clean events topic. That's how we filtered them out. Now only the events that are fully clean will be saved in the clean events topic. Is that clean events the topic name? Yeah, clean events. That's good. There's one more thing we have to change, which is uh, instead of defining enable auto commit equals true, what we can do is, if we say enable auto commit equals true, it commits right after we consume the data from the topic, right? And it commits the offset right after we consume the data. So if we consume an event and we haven't processed it yet, right? We haven't processed it. It is running this loop, and it just separated key and events. And before it sent the data to producer, if this code or anything happened and this code stopped running, and when we rerun it, it won't start from the event that is not recorded. It starts from the next event because we set auto commit equals true. So to avoid that, to avoid the data loss that we get, we have to set this to false and then commit at the right spot that we want to commit. In practice, should be something like that. So we set the enable auto commit equals false. So we commit it manually whenever we want, and it should be auto committed after executing this if condition here. And say consumer.commit off. Now this commits that offset only after it is sent to producer. Now we don't get any data loss. So to prevent data loss, this what we can do. We can use commit manually instead of using auto commit. Now that's it. We're done with the data cleaning, the streaming processor. Now let's save this and run it, and let's see what happens. Obviously, I will get a lot of errors, but we can fix it. Let's fix them. Say Python stream processor .py. Run it. Starting silver stream processor. That's good. Okay, it is forwarding all the events with no errors. It is so rare that I end up writing a program with no errors for the first, in one shot. And I did write it. Now, yeah, there are a few events that are emitted, like this one right here, dropped. So it says dropped, forwarded. Only the valid events are forwarded and the rest are dropped. Okay, let's check the topic in the UI. By the way, the consumer offsets, you see that? The consumer offsets are saved here. So it creates a separate topic to save the offsets. We talked about it before in the masterclass, but that's fine. Okay, here are the cleaned events, which are divided among the partitions. If you say in the actual raw events topic, we have 313 records, and in the cleaned events, we have 241. So almost 59 plus 72 records are taken out because they're faulty. So that's almost 25%, which we defined. So that confirms the cleaning is working, which means our data, all the data that we have here is clean now. Doesn't have any faulty data. Perfect. Check the raw data. Oh, wait. We're done with it, but this one, I want to show you which are invalid fields, right? I think I messed up with the producer code, and that's why all the invalid fields are null. I think I spelled something wrong here, invalid field. Well, I did not spelled anything wrong. Well, we don't need it anyway. Like I said, it's not needed. I just want to use that column to show you which field is wrong here. Oh, this is null because the is valid is true. That's why it is null. Okay, that makes sense now. Okay, so yeah, it is working fine then. I want to check. Yeah, there you go. Now here is valid is false, which is which the event does have a faulty record, a column, and the faulty column is currency. And the currency here is assigned with null. That's the faulty record that should be taken out. And all these faulty records are taken out in that stream Kafka streaming processor code, and the cleaned events are given to this topic. That's it. So we're done with the silver stage as well in the process. So we're done with this step. Now we have to head to the business ready step, which means we have to first send this silver data into Kafka and store them in a separate table inside the Kafka, and then we convert that or process that. Then we make it business ready and save it in like multiple tables, a couple of tables, and then create a dashboard out of those data. We're almost done. We just have one more step, the dashboard step. We don't worry about that. This project is basically more concentrated on Kafka, which means the data engineering part and not the dashboard. But I am going to create a dashboard, a basic dashboard, that so we will get our target, the destination. Okay, let's begin with that. For the next step, we first have to create a database, a schema, and a table where the data has to land in Snowflake first. And like I said, I'm gonna give you the link for the free trial to start the free trial with Snowflake. You don't need to even enter your payment details in. You just need a unique email to create a free trial account. And then this will be the home page that you will be landing on. From here, to create a database, click on the create symbol here and click on SQL file. Let me zoom this in so you can see like that. And click on SQL file to create an SQL file. Here, create database, KafkaDB. So we are creating a database named KafkaDB. To run it, select that thing, hit Control plus Enter. And at the bottom, you'll see database Kafka_DB successfully created. I'm explaining every single thing about the UI just because if you're a new viewer for this video and you haven't watched my Snowflake masterclass yet, you will still understand. But if you want to, actually understand everything about Snowflake, you can check on the masterclass, the Snowflake masterclass that I created. That's like 3.5 hours. You can check that out. But yes, we created the database. Now we create a schema inside the database. To create a schema, we do that. Now we are creating a schema inside KafkaDB. So we say KafkaDB dot streaming. So it says create a schema inside KafkaDB dot streaming. We don't have to define this, but this is a best practice. We don't have to define KafkaDB again because on top here, right here, it already selected. It already automatically selected KafkaDB right after we created the database using this command, this query. So we don't usually have to, but this is a best practice. Even after that is selected, this is a best practice to run that query, so you can make sure the schema will be created in that particular database. Schema KafkaDB.streaming, run it. You hit Control plus enter, or you hit this uh, run button. Schema streaming successfully created. We have the database. We have the schema in that database created. Now we create a table. To create a table, now we create the table with the table name Kafka underscore events underscore silver, because the data that we're going to ingest into this table will be the silver data that we just uh, cleaned. So this table will be Kafka event silver, and from this table we do a few more transformations to create a couple more tables, which will be the gold layer tables. And yes, this is silver table, and we define the first column as event ID, and the data type for that column is string. Because event ID is just a combination of characters, so we cannot say that is an integer, we say that is a string instead. And then, of course, the customer ID is also string because it has integers and the strings combined together. It goes like cust underscore 105 101, like that, right? So that's why customer ID is a string data type. Now event type should be a string data type. It includes payment or a few other things that we defined, which are, yeah, add to cart, purchase, page view. So they are strings. Event type is string. Whereas amount should not be a string. It should be a number, and the length can be 10, and 2 is the precision after the point. So it cannot exceed 2 decimal points. And 10 is the length of that integer. I mean, the integer part of the decimal. The length of the integer part of the decimal should not exceed 10. Currency is also string, which is USD. And even timestamp is a timestamp data type. So we say timestamp, and then And for Kafka ingestion underscore TS, so this is the Kafka ingestion time. By default, it is current timestamp. If no values gets into this column, default value should be the current timestamp, which is that particular timestamp when the data gets entered into that table. Then a semicolon. And by the way, we use timestamp underscore ntz because so it takes out the time zone. It just stores the time stamp that we give it. It doesn't store the time zone as well. It just stores the timestamp because we don't want our data to have the time zone also in the timestamp, right? So we just exclude it using timestamp underscore ntz. And that's it. Now run it. Okay, unexpected table. Okay, we used create table and table twice. So that should be it. Now run this. Okay, Kafka event silver successfully created, which means if we switch to catalog on the left pane, right here, click on it and refresh this, then you can see our database that we just created, which is KafkaDB. Extend it using the dropdown and extend the streaming schema dropdown. Extend the tables dropdown. There you can see the table that we created, Kafka events underscore silver. Click on it. We defined it with 7 columns, but right now there are no rows. Right here you can see number of rows or 0. But we have the table ready. Now we have to connect to Snowflake. We have to consume the data from the silver and then ingest the data into Snowflake into this Snowflake table. So let's do that. For that, head back to VS Code and create a new file. Here, create it and say Snowflake consumer.py. By the way, for this code, we need 2 more tools to be installed in our environment. And those tools are, let me open that venv, stop this, interrupt that consumer. Now here, those includes pip install Snowflake connector Python because we need that to be installed in the environment to connect to Snowflake. We need that. Snowflake connector Python, and we need pandas here. If you don't know pandas, we use pandas to, when we, work with the data that should be in tabular columns. I mean, we use pandas to work with the data in data frames. So we use pandas here just to convert the data into a data frame, which makes it easier for us to then send it to the Snowflake table data frame. By converting it into data frame, it is a lot easier to actually send it into our Snowflake table, because right now the data we have is in dictionary format. We cannot directly send that data into a Snowflake table. We cannot ingest it. That's why we convert it into a data frame and then we ingest it into the table. And that's why we need pandas here. And we also need PyArrow. Hit enter, install those tools. after we install these tools, we also need to update the requirements.txt that we created. So we're going to run the pip freeze again to store those updated tools plus versions with the versions inside the requirements.txt. This is going to take a few seconds. Okay, there you go. It is done. All right, now let's update the requirements.txt file. Pip freeze, greater than symbol, and then requirements.txt, run it. Now that is updated. These are all the tools that we need to exactly replicate this environment in a different PC. This is updated with, there you go, Snowflake connector Python and pandas and pyarrow. And the first one that we install, Kafka Python, all of them. We close that. Now we start this with importing. Obviously, we need JSON because we encoded a JSON file. We need to convert that back into a dictionary and then a data frame, and then we ingest that into Snowflake table. So we need JSON here. And then from Kafka, we need to import Kafka consumer because we have to consume the data from the stream. We need to import Snowflake connector to connect to Snowflake, and we need to import Snowflake connector.pandas tools, import write pandas to write the pandas data frame into Snowflake. And lastly, we need the important one, which is pandas itself to convert the data into data frame. Okay, we have that. Now let's configure that the consumer. Before that, we have to define the variables, of course. Bootstrap servers. Let me get that from this one. Bootstrap servers, copy, paste it here. And the topic name equals clean events, I think it is. Yeah, clean events. And now create a new group ID. Snowflake loader. Then we define the Snowflake configuration, which includes we define the config in a dictionary as key value pairs. And for the first key, we're going to use user, which will be the user ID that we are giving, that we are letting this consumer be. So if the user you're specifying here as account admin access, this consumer will get the account admin access. So that's how we define the user. And here, this is the spot where we put in our username. Mine is J. And password. And here we put in our password for the account. I forgot the comma. I'm not going to put my password right now. I'll put it when I run it. And then account. And here we put in our account identifier. Snowflake has unique account identifier for every single account. And to get your account identifier, head to Snowflake and click on your username on the bottom left. Click on it. Then click on session details. Right here you can see the Snowflake context, and this ZH1707 dot Central India, and also this part is the account identifier. We cannot copy that for some reason. Oh, I can. Okay, let me try to copy this. I copied the whole thing, but we don't need the whole thing. We just need this part. After the backslashes, starts after the backslashes, ends before the .snowflakecomputing.com. We need only this part for the account identifier. Copy that. Close. Head back to the code. Paste it here. That part. Warehouse. By default, if you're using the default warehouse, that should be compute WH in Snowflake. Or else, if you created one and you don't know what warehouse is running, head to your Snowflake and on the left pane, click on compute warehouses. Here you can see the warehouses that are active. See that? And so here you can see in which warehouse you created your database. We created our database in this warehouse because we can see the query that we ran. We actually ran it in this warehouse. And even in the catalog, it should be somewhere here. Count admin. Okay, well, that's the warehouse you actually run. So you can see which warehouses are active from compute and warehouses, and you have to paste that here, comma, and the next one is the database name. The database that we created is Kafka, capitals, Kafka DB, comma, and then schema is streaming. That's the schema we created. We're done with the Snowflake configuration. Now let's define a variable, say batch size. I'm going to define it as 50. No, say 10. We are going to use that variable, and then I'll explain why we define that batch size. Now we define the consumer using consumer equals Kafka consumer of, and the configuration goes like the topic name first, of course, and the bootstrap server equals bootstrap servers. Copy paste it. Then in group ID will be the group ID that we defined before. Perfect. Enable auto commit. We use false to avoid the data loss. Like I said, we use auto commit false. Auto offset reset equals earliest. And by the way, if you want to actually implement enable auto commit equals false, you have to configure that manually. If you avoid this line, let's say if you configure like that, avoiding that line, it will automatically take this as true. It commits automatically. You don't have to manual commits doesn't work because it auto commits. So you have to uh, choose when to use it and when not to. And here, because this is a consumer, we use key deserializer. In that key deserializer, use lambda. Key dot decode, the same thing that we used before. These two lines, we're going to copy paste it. Perfect. And then SF. We use this Snowflake connector.connect, where we imported that Snowflake connector. We use Snowflake connector.connect, and for the configurations, we use the dictionary that we already defined for the Snowflake configurations. We have to use these double asterisk at the beginning to actually read that dictionary file as configurations. That's why we use those two asterisks at the beginning. And then we print these two strings. These two are static strings, just to make sure Snowflake connector executed successfully. So if we run this program and these two lines got printed, that confirms the program is successfully connected to Snowflake. There is nothing wrong. I mean, there is no error with that part. So they act like logs basically. Now we define an empty list as buffer, and we define a function for this function we send the parameter. I mean, what we say, forgot. Let's call it parameter. We'll send the parameter, which is the data, to this function. And here, I think that's the parameter. Here we convert that into a data frame. We convert the dictionary list of dictionaries into a data frame using pandas, which is aliased as PD at the beginning. We say import pandas aliased with as PD. So we use PD dot data frame records with this line. We converted that list of dictionaries into a data frame and assigned to the variable df, which is to imply that as a data frame. Now we use df.columns equals c dot upper of for c in df.columns. So we pick one column name from the data frame at once and convert that column name into uppercase just to match it with the Snowflake table, because we created the Snowflake table with uppercase column names, right? Let me check that. Home and the new SQL file. But by default, these Snowflake column names will be in uppercase. So to match that with the actual source column names, we have to convert those column names into uppercases because Snowflake saves them as uppercase. Let me show you in practice. You see that? When we defined the table, we did define as lowercase, but Snowflake convert those column names into uppercase like that. So that's why to match them with these columns, we have to convert them. And that is what we did. There is something theoretical that we have to talk about this part. All right. Firstly, let's talk about write pandas. What write pandas method does is it internally write the data frame that we're sending to temporary Parquet files. this and then these Parquet file will be uploaded to a temporary stage in Snowflake, and then using copy into command, this will be copied to the table that we defined. That's how this write pandas method works. But we don't see it because all this stuff, this whole process will be done under the hood. We don't see it. This is the backend process. But just by using this method, we can do that whole thing. Instead of we manually doing it, that will be done under the hood in the backend. And when we run that, write pandas, it will generate 4 variables, which includes the first variable, which is success. This one, this variable will be a bool variable. It says if the copy is successful, that success bool data type will be true. If it is unsuccessful, that will be false. And that is why the data type of that success is boolean. And then for n chunks, sorry, this should be comma, n chunks, it says, like I said, if the data frame is large, is a big data frame, it will be separated into n separate chunks and n separate Parquet files, saved in n separate Parquet files. And the number of chunks the data frame is separated into will be assigned to this, the value of n separate chunks is assigned to n chunks here. And the n rows defines how many rows, how many records got copied into that Snowflake table. And then the last part is this. This is nothing but the extra metadata that is generated when we use write pandas. We assign that to underscore. So yeah, that's how it works. That's how write pandas method work. Without using write pandas, it is a lot harder to copy the data from a data frame to Snowflake table. But write pandas does it all in the background, in the backend. Under the hood, we don't see it. It handles it all. Now that is done. Now Now, just in case, if the copy is not successful, then what happens? This variable will be false, right? Success is Boolean. If it is successful, it is true, or else it is false. It is assigned with false. So if the copy is not successful, that will be false, and we will check if not success, raise exception, Snowflake insert failed. So it raises an exception saying Snowflake insert failed. If that is successful, print into Snowflake. So if that is successful, we print this using f strings. Now we use this dynamic part to print how many rows are actually copied or ingested into the Snowflake table to have the accurate count. Okay. Now we are actually coming to the consumer part. For message in consumer, so it takes one message, event equals, so we are here creating a loop. We take one message at a time from the consumer, and event equals message dot value. We assign the event alone. We don't need the key now because we just ingesting the data into Snowflake. We don't have anything to do with key, so we just take event equals message dot value. We just need the value. Now buffer dot append. We are appending that event or the value to this list, to this empty list. Buffer dot append event ID is to event of event ID. So we're just appending that. Here basically we're creating a list of dictionaries which will be named as buffer. So first dictionary will be the first record and the second dictionary created will be the second record. And these dictionaries will be created one at a time for every loop, every loop for this for loop. First event ID equals event of ID, and then customer ID the same way. You know what? Let me just. Now I have to type in. Okay, we just mapped everything accordingly for every column, for every key, and we mapped every value for every key. Then perfect. Remember when we defined the batch size before at the beginning? Batch size equals 10. What it says is for every loop, it checks if the length of buffer has is exceeding or equals to batch size, which is 10. So only if that list has 10 dictionaries, which is equivalent to 10 events in that list, only then it flushes that to Snowflake, flush to Snowflake, which is the function name we defined here. So it flushes into Snowflake. Wait. Yeah, it flushes into Snowflake, but what oh, no. Oh, I have to take this thing. This is not part of the function, right? Forgot. I mean, I didn't realize that. Okay, I have to take that. I have to indent it right. Okay. Yeah. For every loop, it checks if the length of the buffer is greater than or equal to batch size, which is 10, which means it has to reach 10 dictionaries in that buffer list. Only then it flushes to Snowflake, which is flush to Snowflake of buffer, which is this one, which converts that list of dictionaries into a data frame, and then connects to Snowflake and then flushes it, inserts the rows into Snowflake. That's it, into the Snowflake table. Only if it reaches the buffer size, then it does that flush to Snowflake process, and then after flushing that data into Snowflake, that'll consumer.commit off, that we use consumer.commit off to commit the offset, which means that batch of data is processed. Now commit the offset, because whenever we run that consumer again, it don't process the already processed data. So we manually commit the offsets here after that, and then buffer.clear off. So this is a method, this is a list method. We use buffer.clear off to clear the list, and it starts over again with the empty list from here again, from this one again, and it loops again. It has to reach a list of 10 dictionaries again to actually flush to Snowflake. And if something goes wrong with the flush to Snowflake part, this exception raises. Print error inserting batch and E. That's how it works. I think we are almost done. We are done with this code. Now I'm going to enter the password here and run it. Let me pause the recording. Well, I usually type in the password on camera as well, but I'm going to, change the password after I record the video, but I feel that little bit inconvenient because I just keep changing the password for Snowflake, so I don't want to do that. So that's why I'm not exposing the password for this video. Okay, I saved that file. Now head back to the command prompt, the PowerShell. Here, run Python snowflake consumer.py. I am definitely, I'm so sure I'm going to face an error with this code because this is so lengthy. Okay, we did got connected to Snowflake. Now it is a matter of sending the data. Okay. We haven't got any errors. We did insert 10 rows into Snowflake now. Another 10 rows. All right. Let me run another. What I'm going to do is I'm going to run exit. Now I'm going to start another consumer here with the same consumer group. So this will also consume. This will also connect to Snowflake and consume it. Ingest the data into it. Will it? I don't think we need it. Yeah, we don't need it. Close. Yep, close it. Okay, let's check on the Snowflake page. Refresh. Now we have 240 records which are inserted. Obviously, we do have 241, but we defined the batch size as 10. So it only renders 240 and waits until the other 9 records get inserted and then process the next batch. But for now, we have 240 records here in the data preview. We can actually see the records in the Snowflake, which means we did transfer the data here. Well, I am starting the consumer and the producers and then closing them immediately because this is just a project demonstration. But in real world, we run these producers and consumers in virtual machines, and we keep them alive. We don't interrupt them. We keep them alive. Producer produces the data. I mean, not the producer. We will not have producer that we define. We will have a producer as an external source in real world. We don't use a fake data in real world, right? So yeah, but the consumers will be active 24/7, and yeah, this consumer and also this consumer as well, which is stream processor. These two consumers will be active 24/7 in same virtual machine or different virtual machines. It depends on the load distribution. But here we stop them. We run for certain time to get enough records for us, and then we stop. We don't need that much of data. Okay, we got that. Yeah, we're done processing all the data. Let me interrupt this as well, just to save that computational power. Okay, we're done with everything with our PC. Now you can close your Docker containers, everything. You can close everything. You don't need that. Now we work with Snowflake. We have to process this data to make it business ready and create a couple of tables. Let's do that. Head back to SQL file. Then for the first gold layer table, we're going to create let's create a view. So the data will be updated automatically, will be live according to the source. I mean, will be live connected to the source table. So we create a view here. We can create a table as well, but that makes it a static data. But when we create a view, the data will be updated whenever the source data gets updated. View and say daily customer revenue as select customer ID. So we selected, for this view, we selected the customer ID. I just got a call. Okay. We just select the customer ID, just the actual customer ID, and then from event timestamp, we just select the date part of the timestamp, not the time and everything. We just select the date part and assign it to the event date column, and then Sum of total as total revenue. You know what? First, I'm going to write all the whole query, and then I explain what's going on. Okay, that is one table. That is one view that we're going to create. We're going to create a view by grouping customer ID. So it groups every single customer ID to one. So we will only have one unique customer ID for one unique record for every customer ID, just one record for one customer ID, because we are grouping them. And then no, because we are grouping them with two parameters here, customer ID and the event timestamp. So we only have one unique record, one record for for one unique combination of customer ID plus event timestamp. So we're grouping them. And then where event type equals purchase, so it only has to include the customers with purchase as event type. So only the events with purchase as event type, and the rest will be taken out. Rest will be avoided totally, will not be included in this. And then here select customer ID, date time, date of event timestamp as event date. Now we're going to sum all that whole amount after grouping these two parameters, customer ID and event timestamp. The amount will be summed together for these two combinations and be aliased as total revenue. And then countif event type equals purchase as purchase count. And then we will also use this column to count only the events which has purchase. So it shows how many purchase events and how much of revenue this particular customer has made us. That's how it works. That's how the whole table is. When I say daily customer revenue, it's not about customers' revenue. It is about our revenue from that particular customer. So we're just seeing which customer is generating how much of revenue for us. That's how this view works. Now let me try running it. It is created. Great. Now let's create one more goal table or one more goal view. We use the same, almost the same line for everything, and we say add to cart. The same line, but this time purchase. Purchase. Say purchases from Kafka event silver, group by date of event timestamp. So this is simple logic. What we're doing here is, oh, so we're creating an event funnel to to see the behavior of the users for every single day. So what it does is it groups by event timestamp date. So it groups only one particular day as one column. No, one particular day at a time. Yeah, one particular day as one column, one particular day as one record in that table, and the rest, these three columns will be counted according to how many page views on that day and how many add to carts on the day and how many purchases on that day to track the customer actions, the customer behaviors on that particular day and be saved. That's it. Simple logic. Now let's run that. That is also created. Let's make sure that is created. Head to catalog, click on the views. You can see the both the views are created, and click on one view, data preview. You can see for event funnel, we only used 6 days, right? Oh, we actually used 7. All right. So we used 7 days. And for every single day, how many page views, how many add to carts, how many purchases are recorded here. And the same way for daily customer revenue. So we group by customer ID and the event date. So for this unique combination of customer 3 and this event date, the total revenue generated is $182, and then purchase count is just 1. And likewise, the other columns too, other records too. That's how we aggregated these things. Now we have both the tables which are business ready. Now let's create a dashboard, a basic dashboard out of this. To create a dashboard, let me think what to create first. Yeah, we can create from this event funnel. From this event funnel, we can create what? 3 line charts. One shows the page views per day, and one shows add to cart, and one shows purchases per day. So 3 line charts from this table, this view. And then from this view, we can create uh, we can also create a date, event date. We can just group by event date and create total revenue per day, right? And yeah, we can create a total revenue column which totals up everything we made since we started. I mean, from the past 6 days. So we can create a key KPI card that shows total revenue. We can do that. We can do a lot of things, but let's do a few. Just create a basic dashboard from this. What I'm going to do is I'm going to copy this link and paste it in a different tab like that. And here I'm going to click on the plus symbol here and click on dashboard here. We're going to create a dashboard in Snowflake itself using Snowsite, like I said. Here, let's name our dashboard as e-commerce sales. That should do. Create dashboard, new title, SQL worksheet. Now from this, we have to select the database that we're going to work on, database and schema. Now from this, what we will do is first create the KPI card. Oh no, first let's create the line charts that we said, that we just discussed. We're going to create one for page views, one for add to cart, one for purchases. Select. Page views, comma, event date, right? Page views. Comma, event date, event date. Where should I say where, or should I just, no, I don't need where here. I don't need where clause. We just say from the table name, the view name, which is event funnel. There you go. Run it. We got that. Now switch to chart. There it is. Now we have sales. No, we have page views by time line chart created. We can name it accordingly, saying page views by date or by day. Page views by day, and that's it. That will be created here. In the same way, let's create one for each. I'm going to copy this first because we're going to use the same thing. Edit query. And I'm going to copy this query and just replace the column name. New title, new SQL worksheet. Paste it. Database, schema. And instead of instead of page views, we use add to cart. Perfect. Now run that. Chart, line chart, perfect. Name it. Add to carts by day. Same way, we're going to do that for the third one. Instead of page views, purchases. Purchases, run it. Chart, perfect. Name this purchases by day. Now we have 3 line charts. What I'm going to do is I'm going to drag them so they be side by side. Yeah, I'll leave that like that right now. And one more SQL worksheet. Now we're going to do something with this goal table. So we can do total revenue by day, right? By grouping by event date, we can do that. So let's do that. Kafka streaming, select event date. We do that in which is event date and why am I doing this? Let me minimize that. And then we need total revenue. Use sum of total revenue, okay, from the table name, daily customer revenue, group by event date. That's it. Let's run that. Perfect. Another line chart for that. Name it revenue by day. We have 4. This is the main line chart that says revenue by day. These are the 3 that says, one says page views, add to carts, purchases by day. New worksheet. Let's add a line chart for purchase count by day, maybe. Or yeah, we can do that. We can do that. So what we do is just going to duplicate this and edit this query. Instead of total revenue, I'm going to say purchase count. Perfect. That should do. There you go. And rename the chart as purchase count by day. Perfect. We have 2 line charts. And we now do one KPI, 1 or 2 KPIs. So we select just the sum of total revenue. Title, new SQL worksheet. Streaming. Say sum of total revenue from revenue now daily customer revenue. Right. Run that. That is just one value because we're going to create a KPI card, which is scorecard in Snowflake. Say total revenue. Perfect. Now we have a KPI card as well. So what I'm going to do now is going to say place it right here, and I'm trying to do is do that, do that. This is the problem with Snowflake. We cannot customize it. We can customize it, but not too much. What we can do here is I'm just seeing if I can just segregate them in the right way. So the line charts will be one by one, and then the KPI goes there. Nah. Well, it is what it is, right? We got that. Yeah, in the same way we can create the whole dashboard. But there is a basic dashboard that I just created. But the whole purpose is to focus on the Kafka, right? So we're done with everything. There's the last part. Now, when we check on this, we did use producer.py but to create our own data source, and then we store it in a raw data topic in Kafka, and then we cleaned it using Kafka streaming processing in Python itself, and then stored in a new topic which we used to store the silver data, and then we then ingested the data into Snowflake, then converted it into business ready, and then we created a dashboard out of this business ready data. With that, our project is officially done. And like I said, if you can get every files that I used in this project from the link from the GitHub link in the description. With that being said, I'll be back with another video. Until then, take care.